Hello and welcome to today's webinar, in which you'll learn how to quickly identify and troubleshoot database-related issues impacting application performance. My name is Daniela, and as part of the webinar team, I am your host today. A few housekeeping items before we get started. First, I'm obligated to show you this legal notice slide. The content and materials shown today are confidential and property of Cisco AppDynamics. Moving on, please note that the console you're looking at is completely customizable. That means you can feel free to explore any widgets at the bottom of your screen. Check out the speaker profile. You can ask questions in our Q&A widget and have a look at additional resources. We invite you, of course, to drop any questions that you might have in the Q&A widget. And of course, we're going to answer them at the very end of the session today. Please note that in case we can't come to your question, we're going to reach out to you per email. Lastly, a quick note that this webinar is going to be recorded, and you'll receive a link to the recording within 24 hours after this session today. With that, I'll go ahead and hand it over to Rupesh. Thank you.
Good day, everyone. Welcome to another edition of Moments from the Field webinar from Cisco AppDynamics. I'm Rupesh, Professional Services Consultant with Cisco AppDynamics, focusing on AppDynamics product delivery at customers. So my journey into observability and monitoring started 4 years before. Prior to that, I used to be product consulting. I used to do product consulting for supply chain and retail solutions based on a company called Blue Yonder. In this webinar, we are going to take a quick look at the database monitoring basics before jumping into a quick demo. And I wanted to focus on 3 navigational journeys to help you understand how easy is it to navigate and troubleshoot an issue starting from browser till the database. That's the primary agenda for this particular webinar. So we'll be doing a quick basics, and then we'll be doing a demo. And I'll open the floor at the end of the webinar for more Q&A, and then we'll ask some questions as well regarding, how do I configure highly available databases and so on. Going through the next one, we've just covered the overview. Let's jump into the quick recap of the value of database visibility. So what is database visibility? In a nutshell, the database visibility is a component that resides in AppDynamics that provides insights into what's happening on the database from the perspective of the end user transactions. So how exactly this is going to help the customers on a typical day-to-day journey is with AppDynamics performance monitoring agents. Users are able to troubleshoot or even get a proactive alert if there is a degradation in the performance of their application. So the typical navigation would start from applications, and then they get into the transactions and they're able to drill down and then find out. Now with database visibility, there is an additional level of drill down capability that is available, wherein teams will be able to drill down further into the context of database. Okay, what is taking so much time in my database from this query execution point of view? So that is a very critical component because it reduces a lot of finger pointing, especially when we are in a war room kind of situations, wherein teams are really not sure as to where exactly the performance issue lies in. And like I said, it gives us end-to-end visibility because we are able to track the performance of a transaction starting from browser till the end component, which is the database. And because of the proactiveness of the alerts that we are able to configure, it is going to help us reduce both MTTR and MTTD as well, mean time to diagnose the issue as well. Jumping on, I quickly wanted to touch base on how exactly the database visibility is different. So here I'm going to talk about how the database agents are going to monitor your databases and how is it exactly different from application agents perspective. So from applications perspective, I'll take a quick example. Like if it is a microservices based applications which you have developed and then deployed on a Dockerized kind of environment. Example, if you have got an application deployed on 10 containers, typically you would need application agents also installed on all these 10 containers to monitor it end to end. On contrary, with respect to database visibility, we don't need to have database agents sitting on each of these databases servers. We can have a centralized hosting mechanism wherein there can be one server which has got accessibility to all the 10 databases or multiple databases as long as the connection goes through. So that's how we'll be able to monitor. In a nutshell, it is more like an agentless kind of monitoring because we are not, there is no need to have database agents on all of these servers. And while explaining that from database visibility and agent perspective, while we can say that a single agent can monitor multiple database instances up to 200, it's also important to know that database agents are both horizontally and vertically scalable. And in the field, especially if you're monitoring hundreds of databases, we would highly encourage you to scale it up horizontally. Navigating through. In this slide, I wanted to explain, touch base on the initial topic that we discussed briefly, how exactly the DB agent is going to provide us the additional insights. Typically with our APM agents, we are able to drill down into transaction snapshots and we are able to see which particular call in the snapshot is causing the performance issue. Now that particular call could be a database query, but that's it. So we'll not know further as to why that particular DB query is causing the issue. Now with DB agent, we are able to drill down into the query and then we are able to inspect it using so many visualizations, be it wait states, be it disk and network IO, be it how much time it is actually taking on the server, is it waiting on anything. There's just too many visualizations that I'll take you through in a moment using the demo. So in the next slide, I'll quickly show you without DB agent, what is it that we are able to see just from a visualization perspective. We just talked about it. So here is the visualization thing. So without DB agent, so we are able to drill down into a transaction snapshot. We are able to see there is a call being made to database. We are able to see a query is taking 4.1 seconds, but that's it. We are not able to drill down further and then see what's causing that. Okay. So here is a quick summary of all the points that we have discussed. Now, in addition to it, I wanted to reiterate that with database visibility, we are able to configure proactive alerts on the databases also. So because the database agent is spitting out so many metrics, so many useful metrics from database performance, we are not limited to configuring proactive health rules on just the application end. We are now enabled to configure proactive alerting from database server perspective also. And yeah, the best thing about database visibility is we are able to drill down into query and then inspect the execution plans as well. So for someone with a DevOps or a DBA persona, this will give very good insights as to whether the query is taking the route that they expected or is it deviating from that route, and they'll be able to further tune the queries based on this information. So this is a very valuable insights and information that database visibility is going to provide in addition to the APM visibility. In this slide, so in this slide and then the next couple of slides, I'm going to show you the out-of-the-box database visibility dashboards. I'll not be touch basing on all the individual windows, but here is a very quick glance of it, and we will definitely go through some of them during our demo as well. So this is the landing page of database dashboard. As you can see, at a very high level, based on the time window being selected, we are able to see if there is a predefined pattern to the database usage or if there is any deviations. Example, at 7:30 p.m. if I have had a spike, then I know something is happening during at 7:30 p.m. and I'll be able to drill down into my database and then see what's happening during that particular time. So now this is in addition to what we would see from application perspective. So some of the transactions happening on the database may not be related to application also. So it is very important that we get this visibility with DB agents. One of my favorite widgets in this screen is the top 10 query wait states, because if I were DBA, just by looking at these wait states, I know whether my database is being utilized effectively or it is not being used effectively. So there are some sort of wait events here using which, I'll be able to tell that there is a problem with either database or being the queries that are executing on the database. Navigating through. So this is another interesting extension to the widget that we saw in the previous dashboard. So here the visualizations are just so helpful because here we are able to see out of last 2 hours time window, 32 minutes has been spent on wait for. Now, is this expected or is this not expected is something the DBA or application teams will be able to tell based on the type of databases. So this quickly provides that kind of insight. So, and remember, with the time window being selected, we have the capability to select any dynamic time ranges that we can select. So example, if we were to investigate something that happened earlier, we can drill down during that particular time frame as well. Going through. So queries is another very, very important window. Example, if I were to fine tune my application performance, every day, first thing in the morning, I'll come and then, open this queries window and then see in last one day, what are the top 10 busiest queries. Like here we are seeing top 100, but out of these top 100, what are the top 10 queries? And the top 10 out of top 10 queries, right? Some of them could be genuinely performing very well. So we don't need to, just by looking at the number of executions and average response time, we'll be able to gauge which one of them is poorly performing to our expectations and which one is not poorly performing. So based on this information, we are able to drill down and see the execution plans of this query as well. And then, where is it originating from, who's it using it, and whether it is in line with our expectations as well. So at times we could use this information for auditing purposes as well. Are all the calls coming to database are expected from the clients that we are using, or is there anything else coming outside that? With that, I'd like to take a pause and then quickly jump into the demo block. So here is the landing page of AppDynamics from AD e-commerce browser that we see here. It's a browser-based application that is being monitored with AppDynamics. Now, the moment I get into the application, I can go into pages and Ajax requests here. Now, based on the time window that I'm selecting, last 1 hour, I can see the end user response time is significantly higher for last 4 transactions compared to rest of them. So let's drill down into one of these transactions to see what exactly is happening. Let me drill down into one of these transactions. I'll go to browser snapshots. Now, as you see, this is varying between 500 milliseconds to 10 seconds and then 20 seconds. So from ease of navigation perspective, let me pick up one of this that I've got full call graph. When I double clicked on this particular transaction, looking at the times here, around 11 seconds has been, the end user has been waiting for 11 seconds for this transaction to give them a response. Out of the 11 seconds, 10.6 seconds is being spent on the backend application transaction itself. So let's drill down into this transaction as to why it is taking so much time. Let's drill down into the transaction snapshot that gives us quick insights as to why it is taking so much time. Now, a quick look at the transaction snapshot here. Out of the 10.6 seconds that we inspected earlier, 9.4 seconds is being spent on a database query. That we can clearly see here, 9.5 seconds. Now, this is what I was telling. Without database agents, this is the end of it. We are not able to drill down further and then see why exactly the query is taking 9.4 seconds. So we don't have any further insights, and we had to rely on some experts like database administrators to then inspect the database during that particular timestamp and then see what's happening. So in here there's less amount of handshakes because of the database agent present here. As an application user, I'm able to just click on this drill down and then see which query is being executed and how much time. Remember here, it's not one query that is taking entire 9.6 seconds. Now this particular query has been initiated for around 61 times, and the average response time is 1.6 seconds. So let's drill down into this query to see what's happening from this query perspective and is it performing the same. Now, if you recall, we started from user experience, we looked at the transaction, we drilled down, and we were in applications. And the third drill down, we are into the query level details. Now, this is the beauty of it. In just a matter of 3 clicks, we are able to navigate from end user experience to the end DB query. Okay, now let's inspect this particular query execution plan as to why it is taking so much time. Now I'm in execution plan window. I'm clicking on a cached execution plan here. Now a quick look at the execution plan, right? I can see what are the top plan operations here. Now there are 2 tables being accessed full. I'm not sure whether there are indexes on them, whether I can make use of indexes to reduce this particular impact. And there's something called merge join that's happening between the 3rd operation and the 9th operation. Now, is this something that I can do? Like, now this gives me insights to either fine tune the query or to change the underlying objects so that the query response time is improved. Now, this kind of insights typically is not available without database visibility. Now, this is very important for it from a developer perspective. So today, if I'm making a change to an object, how is this object impacting my application, not just database? Is it impacting in a positive manner or is it impacting in a negative manner? So example, if I make a change and if it has taken a different execution plan, there would be another plan hash value also, and we'll be able to quickly compare based on the time window being selected which plan hash value is working better, and we can take this information as evidence to database administrators and then get it fine-tuned and fixed it. Now this is the first navigation that I wanted to show you, starting from user experience to applications to database in the matter of 3 clicks, and then inspecting the execution plans. And inspecting the execution plans, how exactly it's going to help you fine-tune your either query or your database objects itself. The second navigation that I wanted to show you all is in this particular screen that you are seeing, there's something called business transactions that are available. See here, now based on the example, I don't even need to get into user experience and applications. If I were to focus on which transactions are causing good amount of load on my database, I can just get into the databases itself. I can select the time window that I wanted to troubleshoot. And instead of even looking into queries, because looking at queries, we might not know which transaction is initiating it. I'm just getting into business transactions here, and then I'm seeing all the transactions based on the time window being selected. Now I'm able to drill down from here, right? I'm able to drill down and then see this particular transaction has initiated 2 queries. It could be 10 queries or it could be 1 query, how many times it is being invoked. We'll be able to see all of them into further drill downs as well. So this is a very unique capability, because from databases perspective also, we are able to see which transactions are causing the significant amount of load on your databases. Now this gives us an opportunity to then go back and then inspect the application code if it is calling these queries in an appropriate manner, or is there an opportunity for us to then fine-tune them. The third navigational element that I wanted to show you was if I get into an databases, now under queries, now example, this queries window is something that we have gone through earlier. Now under queries tab, example, if I were to drill down onto a query, even here we are able to see which transactions are initiating this particular SQL query. Now this also gives very insight. Example, if it is an API that is invoking, if there are 10 APIs invoking a database query, out of all the 10 APIs, we'll be able to see and differentiate them as to which APIs are invoking these queries, how many number of times. This also gives us a unique visibility to then go back and then introspect our application architecture, whether it is working in line to our expectations or not. The final navigation that I wanted to show you all is, example, we have seen how exactly we are able to navigate from user experience to applications and then to database queries. Now, under the hood, like the database, if the database is present on a host, is the host also performing to the expectations of the database? Is the database starving on any resources? So how do we address that? How do we know that? Example, the CPU and memory used percentages that we are seeing here. How is it possible and how are we able to see these accurate values? So this is possible if we have AppDynamics machine agent also installed on the database host. See here the server dashboard. This controller is intelligent enough to discover the IP addresses of your underlying database nodes and then map it accordingly. And you see the edit tab, right? So if the mapping doesn't happen automatically, we have the access to then go and look up the server and then map it accordingly. So this access is present. So with this one, it is very simple. In a matter of just one button click, I'm able to navigate to the host where the DB is present and then investigate the host performance also. Example, if my memory is being utilized high, if my CPU is being utilized high, or example, if I've got additional capacity, can I fine tune my database to improve the performance? Now, because most of the servers these days are virtualized, I typically tend to look at the swap usage and steal to make sure the host itself is not starving for any CPU cycles due to virtualization. These two are very important metrics. So this is the last navigation that I wanted to show you. Now let's get back to our presentation. This is one of the topic that I've been asked by so many customers when helping them monitor their applications using AppDynamics. How do I configure AppDynamics to monitor my database architectures? Example, I've got an Oracle real application cluster. It has got high availability. It has got 3 nodes underneath it. It has got 4 nodes underneath it. No, and some of the customers will tell, no, I have got SQL Server clusters with always on availability group enabled. I've got 2 copies underneath it. How do I monitor them? And the very simple answer that I would tend to give them is, just think how you would establish the connection from an application perspective. If your application is also talking to these databases, obviously you don't want your application code to be changed whenever the database goes from primary to secondary, or if there is primary to failover nodes. So typically the applications will be using JDBC connection strings to cater for this high availability. And I would suggest customers also to make use of the same JDBC related connectivities when configuring AppDynamics database collector also. That way, in the instance of failover, AppD agent automatically discovers the new failover nodes and it monitors those databases seamlessly, so that there's absolutely no manual intervention. And in terms of Oracle RAC, so AppDynamics provides the visibility into all the underlying nodes out of the box. You don't need to do anything. Example, if it is a cluster with 4 active nodes underneath it, all 4 active nodes would be discovered out of the box and it will be shown. And we quickly discussed about SQL Server AG cluster as well, right? So this is also possible with AppD, and we are able to monitor all the worker nodes. And in some cases, some customers do ask us, okay, I've got a primary database and I've got a secondary database opened in read-only mode, and I want to monitor the secondary database also. In that case, the JDBC connection string might still not be helping them. So what I suggest them is to make use of the subcollectors functionality in AppDynamics, wherein the primary connection will be established at the read-write copy of the database, and using subcollector, we can configure additional connections to establish to read-only copy. That way, both read-write and read-only copies also will be shown in the AppDynamics topology. So this is also very helpful for them because the dynamic baselines are established against all these databases and metrics, and they're able to make the best of it. And another question that I get asked most of the times is, okay, the metrics being shown here are not sufficient to us. What do I do? Especially there are some application teams that come to me asking, I need to fetch so and so values from the database because that is very critical for me to monitor my business functionality. And some DBA teams would come in, okay, these metrics are really great, but I want to monitor these 4 specific parameters out there because they impact my database. In such cases, I suggest them, to make use of the AppDynamics custom metrics functionality. And then the moment they create the custom metrics, again, the best and beautiful part of it is the dynamic baselines are already there. So you could make use of the dynamic baselines to alert you, or you can configure a health rule against static thresholds as well. At a very high level, these are all the components that I wanted to discuss in this webinar, and I'm opening the floor for Q&A. Thank you. Thanks everyone for chiming into the webinar and then asking some questions as well. So I've got 3 questions. I'll read them aloud and then I'll start answering them as well. Tim Wilson asked if the feature that we were talking about in the webinar is DB type agnostic. Yes, it is. So you are able to drill down into the database queries for all the types of databases that are being monitored by AppDynamics. The second question, Vishwa Mohan has asked, is there any way to know long-running queries individually? I think after you asked this question, I did go through the queries window where we saw the top 10 queries or top 100 queries, and then we drilled down into one of those queries again, to inspect which one of them were actually long-running, which instances of those queries were long-running. So that will help you answer this question. The next question was again from Tim Wilson. When was the DB visibility feature released? I'm not sure about the exact date though, but it was a feature that's existing since I joined AppDynamics in 2019. So it's definitely more than 4 or 5 years old. Thanks everyone.